So I'm going to talk about they're talking about linker scripts. Okay, well, I don't have a linker. First of all, there's only two binary files, kernel.bin and compiler.bin, and there never needs to be any more binary files. When the users write games, they write source code, and then they run them with F5 as okay. So it's like, so you never have object files, you never have binary files, all you have is source files. Okay, so so if you go to my kernel directory, there's a project file, and this might sound laughably amateur. All it is include files. This is the closest thing to a linker script. There's not a linker. All it is include files. Doesn't that sound laughably amateur? But the point is, you don't need if you have a lot of memory, you can link the whole thing in memory. And it's anyway, linkers are outdated. Anyway, so there is no linker. So what does it do? It puts, there's no segments, there's no code segment, there's no BSS segment, there's no segments. Okay, what it does is when it hits code, okay, the compiler doesn't have any code, but when it hits code, it just puts it right there at that spot. So when it's compiling code, it doesn't have segments. It just puts the code right there. If it sees a variable, it just puts it right there. It puts a space for the variable. So when you right here is where it includes the global variables, and what happens is this reserves space in the binary. So that means the binary has a big segment of zeros, okay? So, or not a segment, a big chunk of zeros. Okay, so I don't have support for ELF. All I do is my binaries just put the code right when it starts compiling C code, it compiles function by function and it puts the code right in place. If you have text, then the text gets placed right after the function. So let's take a look at this undefined def. So let's look at that. Unassemble, address, undefined. I think it's just undefined, defined. Okay, so it put the function is in memory. I have my debugger understands my compiler. The kernel has a map file that teaches the compiler where everything is. You can't see it, but there's some all the offsets of the line numbers are there. So this has symbolic debugging. And then look at this, right after the return, it has 24 4C 54. That's the ASCII that was right in the function. So the ASCII that's in the function gets the text that's in the function gets placed right after the function. So I don't know. There's some people that did you know there's people that have no clue that the command line can be anything but Unix? I swear there are people. They never saw a Commodore command line. Have you ever seen the Commodore command line? Let's see if there's a website. I bet there's an online website. What do we call this? Okay. Let's see it. Okay, so this is the Commodore. Now watch this. Print Shift 2, I remember. Hello. Okay, so this, if you say print okay, so what you type, if you don't put a line number, it executes immediately. If you do put a line number, there are people who, I swear, they cannot imagine anything but Unix. Oh, damn it. They act like, of course it has to work like Unix. No, it doesn't have to work like Unix. We're entering a basic program. So when we say list, this program is in memory. Now we say run. Okay. So that's a Commodore. Watch this. U0, whatever. My function. Now we say while true, hello. Now we say my function. Now we say who minus r. So there's, this is what's in the symbol table. There's a couple functions. Now if we say unassemble function, okay, unassemble function, my function. Hello? Hello? So this is a function that's in memory, okay? And I just listed it. We can't change it, but anyway, you can see that the text is right after there. Okay, so now if we say, so there are people that give me a blank stare and act like there's no other possible way that a command line could function. I want to beat the fucking shit out of them. How can you be? Of course you can do other ways of making a command line. They think that if you type some text, they think that it has to be a file. I'm saying, what the fuck? Didn't you ever see a Commodore? What the hell is your problem? And they look at me with big eyes and just stare at me like, what? Fucking retards. Okay, so So I made a binary file. There's a on the supplemental disk, there's some utilities. One of them is binrep. There's only two binary files, the compiler and the kernel. So if we go to the compiler directory, there's the compiler binary file. Now we're going to dump it. So first we're going to say doc max. This makes the command line buffer large. Now we say binrep compiler. So this is what's in my binary file. There's the flat text, the flat binary. There's the flat binary code, and then there's a list of absolute addresses that have to be patched. So first of all, my code in my binaries cannot run until the absolute addresses are patched. The kernel patches itself. That's pretty crazy, isn't it? So it's got self-modifying code that patches. So that means you can load the kernel anywhere in the low 640, and it will patch itself. So these are the absolute addresses that have to be patched before you can run the code. This is the exports. It puts these into the symbol table as exports. You have to bind a header if you want to call them. And then here's the imports. No, yeah, these are the imports. No, what am I talking about? Yeah, these are import. What? Yeah, these are imports. There's multiple calls to malloc. My dog wants it. So global variables are, most of these are relative addresses. These are absolute. So the global variables are gaps in the binary file. If that's not what you want, use malloc, because anyway. Oh, and everybody thinks that 7F is heap, or is a stack. As soon as somebody sees a number like 7FFF, they go, oh, that's stack. No, it's not stack. Oh, that's stack. No, it's not stack. I don't use paging. This is the memory. This is the physical memory map. I have 13 times 4. 13 times 4. I have 52 gig. 52 gig. So I don't use paging. I use paging, but I don't use paging. Anyway, so just the low 2 gig is for code. It's not stack. Okay, all the code goes in the low 2 gig. The rest of it is physical addresses, absolute address. If you call malloc, then you get okay, so it starts shaving off chunks from the top. So this is a big chunk. Wow, what did I do? I did 4 gig. So anyway, start shaving off memory off the top. Okay, so I had a slight error in my last demo video. but it turns out it doesn't matter. In VirtualBox, I did not set the number of CPUs correctly. Okay, this doesn't like, well, I only had one CPU when I did the demonstration, but it's actually worse. Hello? Yeah, it is. Oh, it's OBS. Okay, yeah, you're welcome. Okay, bye. Yeah. Okay, so yeah, okay, they wanted the person asked what was the program I'm using to webcast, and it's OBS. And the reason he might have brought that up, okay, one of the cores just took a shit. Okay, so okay, there it is, multi-core. Okay, so I'm doing a benchmark. You can see that core 0, this is the number of task swaps a second. It looks close to gigahertz, but it's not gigahertz. Anyway, so this is doing, core 0 is crippled. And the reason is because it's doing Linux, isn't it? You see, core 0 has to do this Linux stuff. So that's why I don't have the whole computer to myself. So that's why I don't get the whole computer. So as a matter of fact, when we run the flight simulator, it's not really, it's not any better. It's broken in a different way. Part of that is probably from core 0 being burdened. But anyway, there's a VirtualBox simply, for whatever reason, it doesn't work. It doesn't work for, if you're not doing anything stressful, but that's hoot. If you can't run the flight simulator, forget it. Anyway, by the way, VMware costs $250. VMware costs $250. Hello? Hello? I forgot to mention I paid $250 for VMware. I think there's a VMware player that does not allow mounting disks, but there's a few problems with VMware. Let me tell you what the problems are. Oh, let's check that. Hold on a second here. Let's see if VirtualBox allocates memory. So we're going to, how much memory do we have? VMware is really slow when it allocates memory. It could be from, okay, so we have 9 with 8 zeros after it. 1, 2, 3, 4. I'm looking up here, 9 with 8 places. Okay, so let's see, let's go U8 star B equals malloc 0x8 1 2 3 4 1 2 3 4. Hello? Hello? So this did not work satisfactorily in 1 2 3 4 1 2 3 4. I don't think it's gonna be okay. So the problem is, oh, it worked. That's not too bad. That's not too bad. Well, okay, that was the first time. Okay, you saw how long it took. That's because Linux had to handle its own memory tables. I use 1 gig tables, so mine is phenomenally fast. Okay, we're gonna do it again. Ready? Here we go. So we're writing to 32 gig. It's kind of slow. I'm kind of disappointed. Well, I don't know. So that's writing to 32 gig. Okay, you saw that, right? Okay, in VMware, this operation is messed up. So it looks like VirtualBox gets the #1 prize for fast disk. VirtualBox gets the prize for fast disk. It gets the prize for fast memory, but it's totally garbage for graphics, and it's hello. It's garbage for graphics, and it doesn't have sound. So that's the story. If you do the same thing in let's see what QEMU does. Okay, well, so what the heck? Let's go ahead and modify my script. So we want 6, 4, 1, 2, 3, 1, 2, 3. Let's not do 6, 4. I don't want to leave myself stranded. Okay, so we're going to do 60. I'm going to save it. I might as well do the others. Oh, wait a minute, what did I do? That's just crazy. What are you doing? You crazy, silly person. Okay, we want 60,000. Okay. That's 60 meg. 60 gig. 60 gig. Okay. So, and the final one, there's new, let's see, no CD-ROM, 60. Okay. Let me see. EMU, we did Dropbox. Let's do it. 60,000. I should see if it works. Okay. Install, no. Move. New, we did new. We did no CD-ROM. Okay, that's all. Okay, so now we do, well, I'm going to check the memory situation. Okay, so we have all the memory in the world. So we say U A star B equals. I bet this works. I think just VMware is messed up. 1, 2, 3, 4. 1, 2, 3, 4. Mem set. Oops. B counter. 1, 2, 3, 4. 1, 2, 3, 4. 1, 1,000. 2, 1,000. 3, 1,000. 4, 1,000. 5, 1,000. 6, 1,000. 7, 1,000. So if it's doing 2 meg pages or 4K pages or one, oh wow, that was fast. Okay, so that's good. Wow, that's fast. Okay, so that's impressive. That's weird. Okay, so I could do a checklist of good and bad. First of all, I use VMware. VMware lets you mount the hard disk. If you pay $250 and you buy this, the sound is, you can't play hymns, but you can do sound effects. The hymns sound like farts or something, but the sound effects, okay, so the disk is pretty fast, but this is broken. If you do what we just did, it takes forever. You can just take my word for it. I don't want to waste time. Anyway, so we already went over the binary file. Yeah, some people are like, well, how can it be anything other than ELF? And I'm like, because I fucking wrote a compiler and it never occurred to me to make it into ELF. Why would I do that? My system is a lot simpler for the compiler. I don't have segments. I don't have a text segment. I don't have a data segment. I don't have a code segment. I just put it right in place when I hit it. If I hit some code, I put some code. If I hit a global variable, I put a spot for a global variable. As a matter of fact, there's a they're not supposed to go into the 2 gig code section when you do a global variable. Let's say U8 B128. So you might ask, where is B? Well, it's in the code area. This is not stack, it's code heap. So I kind of lied about that, didn't I? But if you do U8, I don't know, pointer. If you do U8 pointer and then you say pointer equals alloc 0x1, 1, 2, 3, 4, 1, 2, 3, 4. If you allocate off the heap, then it is not in the lowest 2 gig. So global variables, now the reason global variables are in the, I lied about that, is because it's a little bit more efficient for relative addressing. But eventually we're going to probably tell everybody to option on option EQU, what option, okay, this is the compiler option number value, and we say OPTF globals on data heap comma on. So now if we say U8 BB, and then we say address BB, now it is not in the lowest 2 gig. It's way, how many is this? 1. It's way up high in memory. This is physical. You might think it's virtual, but I actually have that much physical memory. I have 64 fucking gig. This computer costs $4,200. And it has 24, it has 1220, it's a Xeon. It has 1224, it has 12 cores, 24 if you do hyper threading, and it has 640 gig. And if we go to what am I looking for multi-core? I haven't gotten used to my menus. There it is. So this does the benchmark on the cores. We have 16 cores. VMware will not do 24 cores. So the bad things about VMware, it only does 16 cores maximum. When you change to full screen, you hit Control Alt Enter. But every time you do it, you have to change it back to auto fit and then stretch. Now, the speed is good. In QEMU, there's one mode that's fast and one mode that's slow. Graphics are, this is as good as it gets. Okay, so that's why I use VMware. It does full screen. It does, the graphics are fast. And the problem is, this is bad. This is broken. This is not acceptable. If I say, if I do this, then I'm just going to show you 0x. I'm going to do let's say 4 1 2 3 1 2 3 4. So this is just a tiny. So just to do a tiny chunk. Okay, you saw how long it took. Now we're going to do it again. Pow! You see how much faster? So the second time it's really fast. That's because VMware must be using 4K pages. I'm using gig pages. Is that awesome or what? Okay, so anyway, you don't know what that means. Anyway, once I identity map, I never touch them. Okay, so now we're going to go up to 8. This is half of 4 gig. Fast. Now we're going to go 3/4 of 4 gig. Now we're going to go 4 gig. Okay, so you see how fast it is. Now if we go another 4 gig, this is going to take forever. So it must be mapping them with 4K pages, and it's really struggling. So VMware does not get the prize for memory. They might not get the prize for disk. The graphics are good. The sound, how hard can it be? QEMU got harmonic sound. So this takes forever. So this is messed up, isn't it? This is I have a hard time convincing people this is not my fault, but you saw it when I did the other two. Those worked. This is not my fault. So the first time it takes, what the hell is it doing? It's almost as though it's virtual disk memory. That's what it's at. That's what it acts like. It's acting like it's virtual disk memory. Maybe if I reduced it a little bit, it would start using. I'm gonna wait because you'll see the second time it's really fast. They should all have the same speed on the second time, because that has nothing to do with the hypervisor. Sometimes I get the terms kind of screwed up. Hypervisor. Nobody says that. Virtualizer. There's a problem because some people call virtual machines emulator. They call emulators virtual machines, and I really don't want to confuse people. This is ridiculous. But it's not my fault. This motherfucker is. How can that be acceptable for everybody else? What is your malfunction? We've waited this long, we have to wait. When I fucking ridiculous. It's like it's using disk. I wonder if they have some options for acceleration and stuff like that. I wonder if there's an option that says there really aren't that many bells and whistles. These are pretty minimal interfaces. They're pretty wise. Oh, come on. You gotta be kidding me. Come on. Come on, you stupid thing. Now I'm beginning to wonder. No, it's gonna work. So, oh, there. See, I told you it worked. I have a calibrated timer, and my cursor's blinking fast because my calibration got freaked out. Okay. Anyway, so watch this. That was the first time. Now, once it's been allocated, pow! Watch it. Boom! See what you see that? You see that? Okay. So, I do my allocation without touching the memory. This is when it actually touches the memory, when it sets it. Anyway, I have the fastest memory allocator because it's identity mapped and virtual is identical to physical. Nobody has as fast a memory allocator as I do, which is kind of like saying DOS. Except it's 64-bit and flat. Okay, that's where I wanted to show off. So the people are like, well, where's your ELF sections of your binary? I'm like, dude, I just wrote the compiler. It didn't occur to me that I needed ELF sections of my fucking binary. I just shoved the data right after the code, and that's what I did. Why would I want to make sections when all I have to do is just shove the stuff in there? Anyway, so